Experimental testing method to characterize the drapability of UD non-crimp fabrics used in wind turbine blades. Motivation. Despite extensive research on the detection of fiber wrinkles and their impact on the mechanical performance of fiber-reinforced composites, there remains a notable research gap concerning the assessment of fabric wrinkle formation during composite manufacturing. This paper presents a method for characterizing fabric drapability, defining it as an intrinsic property related to the shearing potential between rovings without the formation of wrinkles. The study focuses on analyzing two types of non-crimp fabrics, one with a binder and one without, investigating the evolution of wrinkles in response to applied shear angles. Experimental setup. The setup consists of an Instron universal testing machine fitted with a 1 kN load cell. A parallelogram fixture forms the subsequent component of the setup. While one side of the parallelogram fixture is affixed to the frame, the other side can move freely in the in-plane direction. A metallic wire links the top grip of the UTM to the movable side of the parallelogram fixture through a pulley mechanism. The test fabric is then placed on the fixture and secured using bolts. The upward movement of the top UTM grip initiates a shear action, causing the fabric to form wrinkles. To monitor and analyze the fabric's behavior during shearing, the top surface of the fabric is scanned at different shear angles from 0 to 16 degrees using a blue light 3D scanner. Results and discussion. Investigating the influence of shear angle on wrinkle height and width in non-binder fabric. The average maximum height refers to the arithmetic mean of maximum height values for all the observed wrinkles. Notably, no wrinkles were observed at a shear angle of 4 degrees. This observation indicates that at low shear angles, the fiber rovings possess the ability to slide, thereby avoiding wrinkle formation. After 4 degrees, the backing fibers are stretched, creating a locking phenomenon on the UD rovings. The UD rovings are no longer capable of sliding next to each other, and as the displacement continues to increase, the fabric wrinkles. The width of the wrinkle also shows an increasing trend with an increasing shear angle. Investigating the influence of shear angle on wrinkle height and width in binder fabric. Wrinkles were observed at a shear angle of 4 degrees, with an average maximum height of 10 mm. The binder fabric demonstrated an increasing trend in the average maximum height of wrinkles as the shear angle increased. However, at a shear angle of 12 degrees, the height of the wrinkles reached a constant value. The width of the wrinkle shows an increasing trend until a shear angle of 6 degrees, then decreases with increasing shear angle. The binder material acts as a glue between the UD rovings and prevents their movement relative to each other. Due to this phenomenon, coupled with the locking effect from the backing bundles, binder fabrics exhibit a higher average wrinkle height and width than standard fabrics with no binder. The relationship between the ratio of height/width of wrinkles with the applied shear angle. The severity of a wrinkle can be measured by the aspect ratio of its height and width. In this study, on the fabric level, the aspect ratio of 1/10 is considered to be critical. This aspect ratio corresponds to an applied shear angle of 9 degrees and 3 degrees for non-binder fabric and binder fabric, respectively. These results clearly showed the effect of binder on the fabric, reducing the drapability by a factor of 3. Conclusions. A novel methodology has been introduced for characterizing fabric drapability as an intrinsic property associated with the shear angle. A state-of-the-art 3D scanning technique was employed to quantify the aspect ratio at shear angles ranging from 0 degrees to 16 degrees. For the non-binder fabric, a critical aspect ratio of 1/10 corresponded to a shear angle of 9 degrees, while for the binder fabric, it corresponded to a shear angle of 3 degrees. The findings clearly demonstrated the detrimental effect of binders on fabric drapability, resulting in a threefold reduction. Thank you.